all the other slides. All right. So my name is Alex Gantman. That's my Twitter handle. And I'll be talking about what I've seen in the total perspective vortex. Before I get started, I wanted to get a sense for the kind of the tenure distribution in the room. So how many of you have been sort of in the industry for more than 5 years? 10 years? 15 years? All right, so this is more going to be sort of less words of wisdom and more group therapy, I guess. All right. First off, a little about sort of my job. So I work at Qualcomm. Qualcomm makes designs and sells semiconductors primarily for the mobile industry. So, so pretty much all of your smartphones will have either a Snapdragon processor or a modem from Qualcomm inside of it. It's a fairly large company, about 30,000 people, maybe 12,000 software engineers, 8,000 hardware engineers or so. I work in the product security team. That's our logo. It has sharks with laser beams, which don't need explanation, and it has a crocodile, which has a long backstory that I don't have time to go into, but suffice it to say that crocodiles were bred to control the out-of-control shark falcon population, and the shark falcons were introduced to control the wolf pigeons, and sort of that's as much as I'm going to say about it. So I've been in the product security team for 15 years. I started working on security at Qualcomm before there was a product security team. I joined as a sort of entry-level engineer, worked on risk assessments, threat modeling, static analysis, crypto protocol design, all sorts of stuff. Today I lead the team of just over 50 people, and we're responsible for the security of all of Qualcomm's products. So a little bit more about the products. The core of the business, as I mentioned, is mobile computing, the processors and the software that go onto it. But there's also networking, so Wi-Fi routers, the Wi-Fi cards in your laptops, smart home stuff, wearables, automotive, both telematics and infotainment units, moving into ECUs with sort of self-driving cars, etc., smart cities, Internet of Everything, which is, I guess, everything that's not already captured by those other categories, light bulbs, pacemakers, everything. And then there's some service offerings on top of that in education and healthcare. So kind of a very broad range of technologies, a broad range of use cases, and sort of a very broad range of threat models. So when I was invited to speak and sort of given free rein on what to talk about, I started thinking about, okay, what would be interesting to share after 15 years on the job, and which of the things that I really want to share can I share publicly, and which of the things I can talk about without crawling into a fetal position. And sort of as I was thinking about it and talking to friends at work, one theme kept coming up over and over again, and that was complexity. So this is supposed to be a picture of the universe. So there is just a dizzying sort of array of complex problems that we come across in this job, in multiple domains, not just technology, and a lot of it is really fascinating. So that's what I decided to talk about, and that's why I titled the talk Postcards from the Total Perspective Vortex. For those of you not familiar with Hitchhiker's Guide to the Galaxy, the Total Perspective Vortex is the invention that that allows the subject to see the full complexity and enormity of the universe, and to perceive their insignificance in perspective. So, all right, if there's one, I guess, overarching point I want to make in this presentation, and that's to succeed in our line of business, our line of work, we need to be able to understand and navigate complexity across technology, business ecosystem, and corporate culture. There are no purely technical jobs in our line of work. At least that's what I believe. I used to think that they're purely technical roles, but I don't anymore. Alex is laughing. He's the CTO. So I'll go into a little bit of that later. But if you are in a position where you can focus exclusively on technical parts, it is because somebody else is taking care of the other aspects for you, and I hope you're sufficiently appreciative to them for that. All right, so complexity in technology. Let me start with the SoC that's in the phone. So I wanted to bring a sample, but I didn't. So imagine that, that chip is about the size of a micro SD card, right? So this is kind of a picture of one of the recent ones, blown up and with the different components superimposed on it. And what I want to, I guess, explain today is that a chip is not really a processor. A modern SoC is really a network of systems on a chip, right? So each of those boxes is a separate processor with a separate software stack running on it. In many cases, there's like a full-blown OS. Many of them running multi-million lines, many millions lines of code on them. So the CPU one up on top, that's that's sort of the multi-core CPU that runs what we call the high-level operating systems, like Android or whatever, and the apps. But then there are all these other systems, right? The modem and the connectivity and engine and the GPU and so on, and all of them, talk to each other and they use shared resources on this network. And we have to worry about what happens if you get code execution on one of them. Can you jump laterally and get resources from one of the other boxes or boxes on a picture? How do you properly set up access control and so on? I was recently sitting in on a code review for one of the modules, and I realized that I needed to get a better understanding for how the memory subsystem was working. So I decided to spend more time and talk to our experts and figure out how does a load instruction actually work. Like load value at address P into register R. And I have the high-level understanding that we all have from computer architecture class. You go through the MMU and caches and so on. But many weeks later, I realized that I understand very, very little about how computers work. It is the amount of complexity involved, the amount of functional units that are involved in figuring out which actual physical location to look up, and figuring out whether the current execution context has the access rights to that location, is insane. I could probably spend this entire presentation just on a load instruction and only provide a very cursory overview of it. And that's that's example of complexity at sort of just the chip level, right? You can go, you can go lower down into sort of the gates on the circuit level, go further down into silicon and sort of security issues at that level. You can go up to board level, then you introduce different interfaces. Then you have to deal with the security of the cellular network, and then you get to the Android framework, and then the apps. Right, most of this conference is about the apps part, right? It's kind of, and even within this slice, there's incredible complexity. Now imagine scaling it up across all of those layers, right? And then you have the users, and some users are more high risk than other users, and pretty soon you kind of go, and you're back to the complexity of the entire universe. And this is just for mobile, right? And then you have to figure out, well, how is it different for pacemakers, or how is it different for light bulbs, or how is it different for cars? So what do we do when faced with complexity in technology? How do we deal with like a lot of complexity in tech? Thank you, Alex. Look at that. Abstractions. But I think abstractions fail us. So abstraction allows us to deal with complexity by essentially hiding it. And that's sort of both its promise and the curse. And as Sergey Broda says, layers of abstraction become boundaries of competence, right? I mean, that's what they're meant to do. They're meant to keep the complexity sort of hidden from you. So once you have the abstraction, you no longer understand how the thing really works. So, kind of to have a very simplified graphical thing here, you have a very nice and neat abstraction. You have reality that's not quite so nice and neat. It has more complex rounded corners, and there's a little bit of delta between them, and there's a very technical term for it in security for that delta between abstraction and reality. It's the vulnerability. So, and if what you see is sort of from the defender's point of view, from the system builder's point of view, you have this nice solid brick wall made out of solid abstractions, and from the attacker's point of view, you have a wall full of holes. And I think pretty much every vulnerability type or exploit type we can think of falls into this category. There's something the attacker understands about how the system really works that the defender forgot, or the defender oversimplified. So, okay, there's one technical question. So, very, very simple technical question. So, assuming most people in the room know binary, this is going to be a binary question. I made it as simple as possible. I made it just one-digit math. What is the range of values that can be represented by a one-bit int? Anybody? 0 to 1. Okay, who thinks 0 to 1? Okay. Okay, who thinks not 0 to 1? Okay, at least nobody gets -0. All right, so here's a hint. Remember the formula. Okay, so what is the range of values? -1 to 0. Yes. So if you have a one-bit int, like in a C struct or whatever, it can never be 1. If you compare that value to 1, it will fail, because it can either be -1 or 0. And when you compare it to 1, the compiler will sign, extend it, and so on. So this was from a real bug, by the way, that we traced down. There was actually, sorry, I'll spend a little bit more time on this. This was years ago when we were still running lint, as opposed to more modern static analysis tools. And lint complained. It said, look, the value that you're testing, comparing to 1, can never be 1. 1 is outside the range for this field. How can 1 be outside the range for anything, right? It's like it's a one-bit thing. How can, it took us a while, but we figured it out. All right. So how do we deal with it? I think our main tool is sort of getting really good people. So we try to hire people who are strong, broad generalists in security, but then are world-class experts in some very, more narrow niche, right? And they can complement each other, and they can rely on each other's expertise. People that are able to pierce through multiple layers of abstraction, right? And can know when they're maybe relying on oversimplified assumptions and know when to sort of ask the right questions. The other one, and many people here may not agree with me, is reverse engineering. I think as the complexity of our systems increases, we're more than ever reliant on reverse engineering to tell us what these systems are really capable of. Right? There are some properties that are going to be emergent, that are not going to be clear from the design or from the source code or from anything else. And reverse engineering is how we know what our systems are really capable of. All right, I'm going to move on to complexity in the business ecosystem. All right, so this is where I explain why you can't focus on the technology alone. So you all know that you can't bolt security on, you have to build it in. And if you're going to build it in, and presumably you haven't been building it in before, or not enough of it before, that means you have to change how your products are being built, and how they're being configured, and how they're being sold and deployed, etc. And in order to change all of that, you have to understand how all of that works. You have to understand, who buys your products, who the customers are, what partners and suppliers you have, what are their interests, and are they aligned with yours? Right. Let me jump to this one here. Sorry. So most of you, or many of you probably know some version of this cartoon, right? It's a project management cartoon, right? It's, how the customer explained it, how it was understood, how it was implemented, how it was sold, and what the customer really wanted. So I was looking at it. I thought, well, not coincidentally, right? A lot of these cells map onto the software development lifecycle stages. And we talk about secure development lifecycle and sort of having touch points at the different development lifecycle stages. Well, if the product looks so different at each of those, which version are you reviewing? Right, so here's the security version of it, right? So there was some feature that was requested, and you kind of do a high-level threat model in your head. Hey, that doesn't sound too bad, but we should probably assign somebody to look at it. Then you request documentation, you get nothing. And then, you finally get to analyze the design, and you propose the mitigations, because, the one piece of wood is not strong enough, so you make them put 3. Uh, and then eventually, the code is complete and they want you to review it. And, the team that reviews the code, do they ever talk to the people that reviewed the design? Do they know sort of what feature was requested in the first place? But anyway, so they review the code and maybe even the bugs are fixed. And then you want to pen test the final product. And the configuration that you were given to pen test has all the features that you care about turned off. So the pen test comes in clean because there's no bugs. And then you have the deployment, and then Sammy comes to Black Hat and talks about your product. And then after that, you really take security seriously. And all the meanwhile, your competitor is selling something so crazily insecure that you don't even, and nobody cares. So how well do you know your what I call the software supply and distribution chain, right? This is kind of the cradle to grave, or developer's keyboard to the landfill flow of your software. Do you know what IDEs are being used? What revision control system is being used? Do they know how they use it? Are you sure they're not launching stuff from shipping stuff from developer sandbox branches or old revisions? What's the release management process like? Test infrastructure, et cetera. Landfill, and for some of us, it doesn't end in the landfill. For those companies that have to worry about kind of gray market recycling, then it extends past the landfill, and here it actually extends pre-developer's keyboard because you have to worry about product sort of requirements and so on. So let me talk about a few kind of motivating examples. So a few years ago, Mattel had a problem with lead paint on their toys. So European, that's that case down at the bottom. One of their European retailers did some independent testing and notified them that they detected lead on paint, or lead in paint on their toys. Within a week, Mattel identified the supplier in China that was using contaminated paint. Within one more week, they tracked down and pulled from store shelves and from warehouses all tainted products. That was, in my mind, remarkably efficient. Now, by the way, they deserve a lot of credit because they went out of their way to prevent something like this from happening. They were actually providing lead-free paint to the supplier, who was then, to use on their toys. He was reselling it and buying cheaper paint with, So, but can you do that? I mean, unless all your properties are kind of web properties, if you're actually shipping product sort of that runs on systems that you don't own, can you do that? Given, when a bug report comes in, and okay, this device has this bug, can you trace it back to, what we call patient 0, the very first time that bug appears in your revision control system? And from there, can you trace it forward to all the product lines, all the branches, all the products in the field that right now have this bug? And can you propagate the fix then to them? And who are you reliant on that, right? If the bug was provided by a supplier of yours, how much visibility do you have into their supply chain? And how much accountability do they have to you? Will they have to fix it when you point it out? And on the distributor side, same thing. If you're reliant on somebody else like we are, we don't sell the final product to the consumer. We have to give the fix to a device manufacturer. Will they propagate it forward? The other inspirational case here was on how researchers started measuring drug usage in cities. So before they would do like poll, they would ask people, they would do random samples. Then eventually somebody had the bright idea that you can just go to the sewage treatment plants and test there, because everybody eventually uses the bathroom, and it all goes out there, and sort of you could get very accurate citywide information, sometimes better resolution than citywide, on what's actually happening. So we tried to take the following approach, right? I mean, we tried to imitate this approach in many cases. It's great to intersect your development pipeline at different stages, but don't forget to actually look at what comes out at the very end, right? Actually, go out and buy the commercial version of the device, and see how it ended up being configured, what version of, what features are turned on, what version of the build is on it, etc. So actually, I'm going faster than I thought it would be. All right, corporate culture. So this is the first point I want to make is I want to encourage you to stay away from the us versus them attitude, where it's sort of us are the security people and them are the developers or business people or anybody else, right? It generally doesn't work well. Almost always you have the same shared goal. You all want the company to succeed. You may disagree on what that means, and what that requires in this particular instance, but you do have a shared overarching goal. And don't forget to treat sort of everyone you interact with, both inside the company and outside, with respect, right? They're real people. They have families. They have concerns. Probably most of the stuff they worry about outside of work is way more important than whatever work issue you're discussing. And the other point here is that change takes time, like many years. And it's easy to be fooled or, I guess, misled by the tipping points you see in other companies, because it looks like the change came suddenly to them. Like, yesterday they didn't care about security, and, today they launched a major security initiative. But talk to people that worked there for 10 years leading up to that, and ask them about all the sort of, I guess, sort of all the bodies that made it possible. So be patient and play the long game. Know how to earn and spend political capital, or know how to earn and when to spend it. I think to earn political capital, you have to be credible. You have to know what you're actually talking about, right? Don't bluff. Don't hide behind jargon. Be credible. You have to listen and convince the sort of the people that you work with, the developers, the development leads, that you understand their position, right? That you understand the constraints that they're operating in, you understand their position, and that you're sort of, they have to believe that you're being reasonable. And then I mean, if you're working in security in your company, you care about security more than anybody else in the company, or at least your team cares about security more than any other team. And that means when you're talking about doing something for security, you have to be always willing to do more than your fair share, right? Because if you're not willing to put in more than your fair share, then why are you asking other people to pitch in? Now, the other side of political capital is that you have to make sure not to forget why you're sort of amassing it in the first place, right? There will be times when you want to spend it, right? When you're fighting for, for an important issue, when you want somebody to take on significant risk, and you want them to trust you that this is the right thing. When you make a big mistake and sort of don't want it to be career-ending, those are the reasons why you stock up on political capital ahead of time. How many people have looked at a piece of code or looked at a bug and felt superior? I guess thought like I would never write code like that. How could somebody write code like this? How did we ever hire a person like this? Why are they need a license to use a keyboard? That's like, come on, raise your hand if you, who's, okay. All right, okay, so people that didn't raise their hands, either you're much better person than I am, or you've never seen a bug. Can you, okay, once again, so raise your hand if that was the case. Okay, I want you to keep it up until you go and read this book, right? So, so The Lucifer Effect is a book about the Stanford prison experiment, written by the scientists that conducted the experiment. Stanford prison experiment, if you're not familiar with it, was conducted in the 70s in Stanford. It was a psychology experiment. They basically recruited random people, mostly Stanford grad students, randomly assigned them into two groups, prisoners and guards, And the aim was to run the experiment for 2 weeks to observe, how normal people behave in a prison setting. It had to be called off after 5 days because the levels of abuse reached pretty much Abu Ghraib levels within that time. And this is like random Stanford grad students. Maybe they were more creative than other people would be, but and what was fascinating was, so there are multiple lessons here. One was that people play the role they're assigned. So it's not just that the guards behaved as guards. Prisoners fell into the prisoner role. They had mock parole hearings. People broke down and cried and sort of asked for parole. Nobody ever said, "I'm out. Like I don't want to play the game anymore. Like I'm out of the experiment." So like people stayed in character. And then the other, because this experiment and others are like it were sort of repeated multiple times. Everybody thinks that they would do something different in that situation. In both cases, right? People think they would never be as abusive as a guard, and they would think like if they were a prisoner, they would stand up to authority. Everybody behaves the same way in those roles, right? So if you think you would be a different kind of developer, you're deluding yourself. In the same situation with the same release pressures, you would be doing the same thing. Or at least I would be doing the same thing. I know that sort of if I found myself as a development lead tomorrow, in the environment that I'm in, my code would be on time more often than it would be secure. And it's not because I don't know, it's not because I don't care. It's sort of that's what the incentive system is structured like. The other lesson here is don't hide behind your badge, right? So, having a uniform, having the sunglasses, having the badge, dehumanizes you and anonymizes you, right? And if you ever sort of catch yourself or somebody on your team telling a developer, you have to do this because that's the policy, and they can't actually explain why, why this is the policy, that's a huge red flag, right? That's people just hiding behind the badge. They're not taking personal responsibility for, what they're asking people to do. They're just, do you guys watch Futurama? Brannigan's Law? Like Zab Brannigan, yes. I don't pretend to understand Brannigan's Law. I merely uphold it, right? And that's sort of, so you don't want to be in this shoes. But seriously, like this is the only book I push on people, almost. A related psychology study done in Princeton, also in the early 70s, was the Good Samaritan study. So there's kind of the summary of the abstract. But basically, so I think the subjects here were mostly seminary students. They asked them to prepare a talk and then rush across campus to deliver the talk. And on their way was a person sort of shabbily dressed, clutching his chest. And they measured how many people stopped to offer help. And most people didn't stop. Some people had to step over the guy to get to where they're going, and it didn't help. They primed some of the subjects by asking them to prepare a talk, like a sermon, on the parable of the Good Samaritan. That had no effect. The only variable that had any impact on whether people, on the likelihood of people offering help, was how much time they had to get to the building. The more they were in a hurry, the less likely they were to help. So think about that when you think about your developers, right? It's not that they're not being preached to enough, right? If they're being asked to, most likely they're under a lot of pressure to ship code on time. So, preaching more to them isn't going to help. Figure out how you need to structure these systemic forces, how you need to make sure that incentives are properly aligned, and that doing the right thing is the easy thing and aligned with what they're expected to do anyway. Okay, and this is the last point I want to make. The subtitle there is, friends come and go, but enemies accumulate. So it's it cuts very being in a company. I've been at Qualcomm for almost 20 years, so I think a lot of people. We have this term in the industry, security evangelist, that I never really quite liked. I think what we do has a lot more to do with what I'll call corporate anthropology than evangelism, right? It's trying to understand the corporate culture, figuring out, how does it work? what's sacred, what's not, what are the important things to change and how to change them. And sort of preaching didn't, at least for the environment that I'm in, never really, worked out well. So, you have to know kind of, which crazy guy with the beard is the high priest and which one is just sort of a crazy guy with a beard. You know, pay attention to what happened to the last person that pushed for change, right? That's sort of, is there a VP's office somewhere with heads mounted on the wall? And and develop a broad network. I mean, this might sound sort of cynical, but you need a lot of human intelligence, right? You need to know what's going on in the company, what people are talking about, what people are doing, what pressures the sort of developers in the trenches are feeling. Because what you get from PowerPoint summaries isn't, it's so many layers of abstraction high that it's not necessarily reflective of reality. So I think that gets us back to the universe. So hopefully I didn't depress you too much. So don't panic. There's no. I think the good part is that there's no shortage of challenging problems or opportunities to pursue them. And I think be prepared to fail repeatedly, but hold on to the delusion that someday you will succeed. That's how I stay sane. So, that's it. Questions, comments, Rotten Tomatoes? I don't. I mean, so because I spent all of my time essentially in the industry in the same company, people that have spent a lot of time in other companies, does this resonate? Is your experience totally different? Same? See, heads nodding. Thanks.